And our costs are way down. As you can see, cost of quality is now under $400,000, and our return on investment is over 440%. So pretty good. Now, let's suppose we come to the realization as testers, test managers, that, hey, we actually could do some smart stuff with respect to getting rid of bugs before they even become bugs in the code. So we can introduce static testing. Now let's say that the development manager, the test manager, project managers, product managers, so forth, get together and they agree, yeah, you know what, let's have requirements reviews and design reviews, and let's make the test guys in charge of those since it's static testing activity. And so they do that. So that doesn't necessarily cost anymore. It's just an issue of moment of involvement, making sure that the testers get involved earlier in the project. So we do that. And let's suppose that testers find 150 bugs in those requirements and design specs. Now, first question there, of course, is, well, is that realistic? And the answer is yeah, actually, because again, to refer back to Capers-Jones's studies, about 45% of defects are introduced in requirements and design specs. So that would mean of 1,000 defects, you've got 450 in the requirements and design specifications. And even relatively cursory, not particularly formal specification reviews can easily find a third of those bugs. So a third of 450 is 150. Now, look at what that does to our cost of quality. Something very nice happens here, because you notice that the test team is finding 650 bugs, but the cost is not $65,000. The cost is $50,150, and that's because 150 of the bugs found by the test team were found at the cost of $1. Nice. So now we've got 900 bugs scrubbed out through requirements reviews, design reviews, unit testing, and formal system testing, and perhaps system integration testing, leaving only 100 bugs to go to the customer. So our overall defect removal effectiveness is 90%, which is pretty good. Not that it can't get better, but that's certainly a good number of bugs to find, and obviously a dramatic improvement over what was happening before from a delivered quality point of view. And notice that our cost of quality here, total cost of quality, is down to $235,000 and change, which is quite an improvement, especially considering that we're looking at $82,000 investment. So it's we saved over $500,000 on that $82,000 investment. So that's a 627% return on investment. So very nice. Now, we've been talking so far purely about must-fix bugs, but of course, not every bug that you find has to be fixed. So let's suppose that in addition to the 650 real bugs that we find another 650 that are not must-fix, that are deferrable. Remember, this is a hypothetical case here, but we're going to just assume that. So some number of bugs often do get deferred. Whoops, pardon me. So you might be thinking, well, okay, we found bugs that didn't get fixed. I mean, why is that valuable? Where's the value in that? Well, pardon me, we're having a little technical difficulty here. The value in the bugs that don't get fixed is, I'm sorry, I'm having a little technical problem. Okay, get that back. The value in the bugs that don't get fixed is three dimensions, if you will. One is that you know where the bug is, and you can actually prevent the user from seeing the bug by basically walling off the buggy segment of the program, right, and make the part inaccessible. And that might be a possibility. If you don't want to do that or can't do that, then you can have release notes or errata sheets or something that say, hey, you know, this is a known problem in this area of the code. Don't try doing this or it won't work. Or maybe even better yet, you provide a workaround. So if we can come up with a workaround, then, you know, hey, that's good. Now, one thing I want to point out here is we're putting a value on something, but we have to remember that this is relative. Must-fix bugs are much more valuable than non-must-fix bugs, and one of the things that we sometimes find in test teams is that they find a lot of trivial stuff early in the process and the more important stuff later, and that's a problem. You want to sequence your tests based on risk so that you're finding the really serious problems first. The other thing that's important too is you do have to recognize the difference between a must-fix and a non-must-fix bug, because if a bug is classified as not must-fix and you identify a workaround for it or something like that, but then the customer said, no, that's not okay, you have to fix that, then you're going to incur an external failure cost anyway. So a good cross-functional bug triage process should be in place to try to deal with that, this potential problem of misclassification of bugs. Okay, so how do we calculate the return on investment for a bug that doesn't get fixed? Well, the way that I have done this in the past is you talk to the help desk or tech support staff, and you find out what the average amount of time is for different kinds of calls. So, you know, for a known bug, assuming there's some knowledge base that they can access, a known bug, how much longer does that take, or how much shorter is that, excuse me, than a call for an unknown bug? And then how many bugs, how many support calls per bug on average, which also is something that should be extractable from the customer support databases. And then finally, what is the fully burdened hourly rate for a tech support person? So if we assume that this hypothetical that it takes 15 minutes less to deal with a call for a known bug versus unknown, and that each bug generates on average 5 calls to the support team, and that a support person costs on average $40 per hour in terms of their fully burdened staff costs, then each non-must-fix bug saves $50 when it's detected. Now, notice that this is just looking at the saved time for, you know, the workaround and that sort of thing. The preventing a user from seeing a problem or helping a user avoid a problem. I mean, they're not going to call up and say, oh, you know, thanks for the help in avoiding that problem because I didn't have to call you today. So it's a little harder to quantify those elements, but certainly for the calls that can get disposed of more quickly, we can calculate some of the value of the non-must-fix bug. Okay, now notice that there is no increased cost for the to capture this information. I mean, basically, we're already finding the non-must-fix bugs and documenting them, so the investment remains the same at $82,500. But what I've done here is I've calculated for using the $50 figure at the $650 or 650 bugs, excuse me, found. Then we've got 32,500 as the value of those non-must-fix bugs.